Okay, hello, we're back again for 9.6, which is now dealing with other angles in circles that do not involve the center or the circumference of a circle. So before, the preceding section dealt with angles that have their vertices on the circumference of the circle. We dealt with before that where the vertex was on the center of the circle, so central angles and inscribed angles. Today we're going to deal with angles that happen when chords, secants, or tangents meet. So investigation 1, I want you to go ahead and try to figure out what angles 1, 2, and 3 are based on prior knowledge, based on what you've learned already in this chapter. So go ahead and push pause and then calculate those angles on your own. Okay, so hopefully you remembered, right, that angle 1 is going to be, it's an inscribed angle where, actually I don't like the way that looks, it's an inscribed angle and it's dealing with this part right here, 52 degrees. So if 52 degrees is the arc BC, then we're going to follow that down here to the vertex, which is on the circumference of the circle. So angle 1 must be half of arc BC, so angle 1 must be 26 degrees. Then if we look at angle 2, well, that is dealing with this arc AD, right? So if we look at arc AD, angle 2 is an inscribed angle with its vertex at B, which is on the circumference of the circle. So therefore, angle 2 is half of 102 degrees, which is 51 degrees. So then how do we find angle 3? Well, if angle 1 is 26 degrees, and angle 2 is 51 degrees, and here we have a triangle, we know that 26 degrees plus 51 degrees plus angle x, which I'll call here, must add up to 180 degrees. So now you're going to get your calculator out and you're going to subtract 26 and 51 from 180. So what do you get? You should get 103 degrees, right? But we don't want the 103 degrees because that's our x, and so what do we know about 3 and x? We know they're supplementary to each other. So therefore, angle 3 is actually 77 degrees, which is the 26 and the 51 added together. So angle 3 is 77 degrees. Now, how did that angle relate to the arc measures that were originally given? So if we look at the arc measures that were originally given, that was 102 degrees and that was 52 degrees. So how does the measure of 77 relate to 102 degrees and 52 degrees? Well, you can see here that angle 3 was the same as angle 1 and angle 2 added together. So therefore, angle 1 was half of 52, angle 2 was half of 102, so angle 3 was the sum of half of those two arc measures. Sorry, it was half the sum of those two arc measures. So go ahead and read the theorem and see if you can figure out then what needs to be filled in the blank. It says the measure of an angle formed by two chords that intersect inside a circle. So here are my two chords. They're intersecting inside the circle, is equal to half the sum of the measures of the intercepted arcs. So here are my intercepted arcs, right? 102 degrees, 52 degrees. They create chords. If I connect those arc where they're intercepted, if I connect them together, here's the angle inside the circle. So it's half the sum of the measures of the intercepted arcs. Okay, now down below, instead of discovering, it's just, I'm pretty much just telling you what the theorem is here. So what you need to do is kind of train yourself on seeing the different types of examples you have here. So this is where it gets complicated. It's the visual aspect. It's seeing that we have two secants, right? Secants cut through the circle and they intersect out here and they form this angle right here. We're calling it angle 1. But then you can see we have the arc X. Oops. We have arc X and we have arc Y. So here's arc X. Not liking this very much, sorry. Arc X, and then we have arc Y. So I'm telling you that in order to get this measure, we're going to take the bigger arc, which is arc X, and subtract the smaller arc, which is XY, get that difference, and then we're going to take half of that measure. So this is with two secants intersecting. With two tangents intersecting, so that's the only difference here, right? These are secants, they're cutting through the circle. These are tangents, they're hitting one point on the outside edge of the circle, but the same rule applies. We have this outside arc here, and then we have this other outside arc. So we're going to take the bigger arc, which is X, and we're going to subtract the smaller arc, which is Y, from it. And then we're going to divide that in half to get angle 2, which is where the two tangents intersect. Right, so angle 2 is up here where the two tangents intersect. So it's half the difference of X and Y. And then finally, the same thing is happening over here. It's going to be half the difference of X and Y, except notice this time we have a combination. We have a secant and we have a tangent. And again, they're always intersecting on the outside of the circle. So here we have our bigger arc. We have our bigger arc X, and we're going to subtract our smaller arc Y, right? So X minus Y divided by 2, and that's going to give us angle 3 out here. So just filling in the blank here, it says the measure of an angle formed by two secants, that's first example, two tangents, that's example 2, or a secant and a tangent, that's case 3, drawn from a point outside the circle, so that's what I was trying to emphasize. All three intersect at a point outside the circle. Then it's equal to, well, what do you see here? It's equal to half the difference of the measures of the intercepted arcs. So half the difference of the measures of the intercepted arcs. It's the same for every single case. So now you're going to try to use these two theorems for the back. Right, so here we have this first theorem. It's talking about chords intersecting, and when they intersect, that measure is half the arc measures, the sum of the arc measures. And then down here, we're talking about two secants, two tangents, or secant and a tangent intersecting, and the angle is on the outside of the circle, and it's half the difference. So let's go ahead and turn the paper over and practice using those by trying to fill in all these problems. So you should push pause now, work on your own, work at your own pace, try to solve some of these. You're probably going to flip your paper back and forth, and then you also have to recall the previous information you've learned about inscribed angles, central angles, and tangents to a radius, and all these different things, semicircles, and use that information as well. So push pause and see how you do in a few minutes. Okay, I'm assuming you have tried most of the problems, or maybe just the first 4, and then you're going to pause again and go back and try some more. But what did you think? I think some are pretty tricky. Again, it's all visual. You're looking at chords, where they intersect the arcs, what kind of arcs they create, identifying them. If you're a visual person or you get confused visually, you might want to get out colored highlighters or colored pencils. So I tried to explain these different things with colors, so you can try to follow my mindset here. So we found angle 1, it's 105, or sorry, the measure of angle TVS, which I call it angle 1, is 105 degrees. the measure of angle RVS is then its supplement, which is 75 degrees. So once you find this one, you can find this one. Well, how do you find angle 1? Well, that's the theorem on the front. Remember, it asked you to cite the theorem used. So here are the two chords that create angle 1. So once you get those two chords that create angle 1, then you're looking at the arc measures. So that's 110 and 100. So that's why I have 110. Oh, I don't know what happened over here. Sorry. 110 plus 100 divided by 2 equals 105. So that's how I'm getting my 105, and this one's easy because it's a supplement. Now, how do we get the measure of angle 2? I don't know what's happened here, some of these symbols. So, sorry, that was to get my RVS. Then I had to find the arc of WT right here. So what did I do? Well, I had to use the half 100 minus WT. Now, why did I do that? Because this time, right, sorry, I'm going to start getting messy here. This time you have a secant and a tangent. So we had to take this secant, this arc, the bigger arc, which was 100, and then the smaller arc here, which we don't know. But when we take the difference, half the difference, we should get this angle up here, which is 30. So I multiply by 2, I get 60. Then I switched it so I have positive, so 100 minus 60 equals 40 degrees. So that arc is 40 degrees. If you know that arc is 40 degrees, then plus 100 plus 110, subtract all those from 360, and if my math is correct, you should have gotten 110 degrees. Okay, again, if you're not understanding, you need to ask me questions during class. Okay, moving on to 2 and 3. Here you can see the work. Again, I tried to color coordinate to help you so you can see the different parts. Which theorem are we using? That's what you're trying to figure out. So most of these now are using the theorems. Oops, I'm still in highlighter form. Whoopsie. So there I'm using the theorems at the bottom, the difference, right? So what do we notice? We have these tangents. If we have tangents, we need to take the huge arc, ACB, which is a major arc, and then subtract the minor arc right here. So it's the big one where the tangents intersect. So before I could do that, I had to find this measure first. So once I did that, then I have this one. I subtract them. I get 70. Half of that is 75 degrees. Over here, this was a little more straightforward. I gave you the angle. So now we're going to take, right, measure of AB minus the minor arc, measure of arc AB minus 20 degrees. Take half of that difference. It should give you 10. I multiply by 2. I get 20. And then you do your math. I don't know why all these signs disappeared. So I add 20 to both sides, so I get the measure of the arc. Moving down, again, I tried to color coordinate here. Here's where my chords are. This is 85 degrees. That means the sum of half of the sum must be equal to 85. So 85 equals half the sum. And I just isolate the RS. Again, find this angle up here. So it's the big one minus the little one. Take half of that value. Okay, and finally, question number 6. You should have gotten these angle measures for 1 through 8. So look them over carefully. If you didn't get them, bring your questions to class. You need to pay attention closely to the given information. But look at angles 1 through 8. And again, if you didn't get those answers or any of these answers, or if you're confused by the theorems, please let me know during class when you're doing your assignment, or come up and ask me questions and we'll review it. Okay, I hope it all went well, and I will see you soon.